morning friends. After the discussion of alpha decay, beta decay and gamma decay, we are going to discuss about what is the nuclear fission process and nuclear fusion process. Now today, what is the nuclear fission process? How the fission of the nucleus take place? And due to the fission of the nucleus as a product, what we obtain? Right? Therefore, the question is that explain phenomena of nuclear fission. Or this question is also asked like that way. Define nuclear fission process and explain it. Now, what is the nuclear fission process? For that purpose, when neutrons are bombarded on heavy nucleus, that means the nuclei having the atomic mass number is greater than 230. So due to the bombardment of the neutrons on a heavy nucleus, this heavy nucleus absorbs this neutron and becomes the unstable. And after that, this nucleus is divided in almost two equal mass parts. Divided into two equal mass nucleus. And this phenomena is known as the nuclear fission process. Again, when neutrons are bombarded on heavy nucleus, having the atomic mass number is greater than 230, nucleus absorbs these neutrons and becomes the unstable and get divided into two equal mass nucleus. And this phenomena is known as nuclear fission process. Why the neutron is bombarded with the heavy nucleus? Because inside the nucleus the positive charge proton and outside of the nucleus the electron are revolved in a circular orbit around the nucleus. Here is our nucleus, here the positive charge proton and charge based neutron are living. Now the electron are revolved in outer orbit of this nucleus. If any charged particle is bombarded, so it suffers the Coulombian force due to the electron and also the positive charged nucleus. Here the neutron is the chargeless particle. Neutron is the chargeless particle. Therefore, neutron does not have any Coulombian force has to face. That means no any Coulombian force is act on the neutron during the bombardment on a heavy nucleus. Therefore, neutron is the best projectile particle. Neutron is best projectile particle. Again, the neutron is chargeless, so it does not have to face the Coulombian force, the Coulomb force. Therefore, neutron is the best projectile. Neutron is a best projectile. Again, what is the definition of nuclear fission process? When the neutrons are bombarded on a heavy nucleus, that means the atomic mass number is greater than 230. Nucleus absorbs the neutrons and divided into two almost equal mass nucleus. And this process or this phenomena is known as the nuclear fission process. Why the neutron is required for the bombardment? So the result is that neutron is the chargeless, so it does not have to face any Coulomb force. Thus, the neutron is the best projectile. Right? Now we are discussing about the nuclear fission process. When the slow neutron is bombarded on the uranium nucleus, so it divides into two equal parts. Its nuclear reaction is, again, when the slow neutron are bombarded on the uranium nucleus. Uranium has the atomic mass number is 253, therefore uranium is the heavy nucleus. When the slow neutron is bombarded on the uranium nucleus, so uranium nucleus absorbs this neutron and get divided into two almost equal parts. The reaction is that uranium-92 235. neutron is bombarded, so it absorbs this neutron and becomes again the uranium-92-236 nucleus. That is the unstable nucleus. To get the stability, it divides into two almost equal mass nucleus. One is barium 56-144 plus krypton 3689. And 3 neutrons are produced plus Q amount of energy is released. Here, this Q amount of energy is not directly obtained. It's a bunch of energy. But this energy is obtained in form of the kinetic energy of neutron, also the kinetic energy of the product nucleus, and also in form of the heat energy. Right? Again, when the neutron is bombarded on uranium-92-235, the neutron is absorbed by the uranium nucleus, becomes the unstable uranium-92-236 nuclei. This unstable nuclei of uranium get divided into two parts. One is barium 56-144 plus second is krypton 3689. Plus 3 neutrons are also produced as a product. Plus Q amount of energy is also emitted. Now the other possible reaction is that the same reaction can produce other pairs of the mass fragments. Not each and every time the same product, barium and krypton, are produced. When the neutron is bombarded on the uranium nucleus, there is a possibility more than 20 products having the atomic mass number between the 36 to 56, atomic number 36 to 56 are produced. So the same reaction can produce the other pair of the mass fragments. Its nuclear reaction is again when the neutron is bombarded on uranium-92-235 nuclei. It absorbs and becomes the unstable uranium-92-236. So this unstable uranium nuclei is divided into Sb51-133 plus niobium Np41-99. Plus 4 neutrons are produced plus Q amount of energy is generated. Again, when the neutron is bombarded on uranium-92-235, this neutron is absorbed by the uranium nucleus. Becomes unstable uranium-92-236 nuclei. So this unstable uranium nucleus gets divided into two equal mass nuclei, Sb antimony, having the atomic number 51, atomic mass number 133, plus niobium 4199 plus 4 neutron plus Q amount of energy is released. Another reaction of uranium when the neutron is bombarded on uranium-92-235. Again, this uranium is absorbed by the uranium nucleus, becomes the unstable nuclei of uranium-92-236. So as a product, xenon 54-140 plus strontium 38-94 plus 2 neutron plus Q amount of energy is released. Again, we repeat this reaction again. Neutron is bombarded on uranium-92-235. This neutron is absorbed by the uranium nucleus, becomes the unstable uranium nuclei having atomic number 92-236. Get divided into two equal mass nuclei, xenon 56-140 plus strontium 38-94 plus 2 neutrons are produced as a product plus Q amount of energy is released. Okay. These fission fragments are radioactive and by successive emission of beta particle results in the stable nuclei. Now, these fission fragments are obtained barium, krypton, antimony, niobium, xenon, strontium are also radioactive elements. By successive emission of beta particles, they try to obtain the stable try to convert into the stable nuclei. Now, the nucleon produced in this reaction are fast. What are the nucleon are produced as a product? Here the 3 nucleon, here 4, here 2 nucleon are very fast. Almost having the energy is 2 MeV. And Q is the energy released, and this energy produces almost 200 MeV per fission. Per fission process, the Q is the energy released during the fission process, and its value is approximate 200 MeV energy. Out of this 200 MeV energy, 2 MeV energy is in form of kinetic energy of the nucleon produced as a product. Right? Now listen again, what is the nuclear fission process? That is the important 4 marks question. Define the nuclear fission and explain it. Now what is the fission process? When the neutrons are bombarded on the heavy nuclei, having the atomic mass number is greater than 230, the nucleus absorb the neutrons and divided in almost 2 equal mass nucleus. And this process is known as the nuclear fission. Right? Why the neutron is the best projectile? Neutron is the chargeless particle. It does not have to face the any Coulomb force. Thus, the neutron is the best projectile. Right? Okay. Now, how the nuclear fission take place? So, when the small neutron is bombarded with the heavy nucleus of uranium, it divides into 2 equal parts. The nuclear reaction is uranium-92-235. The neutron is bombarded, so this neutron is absorbed by the uranium nucleus, and as a result, it becomes the unstable uranium nucleus 92-236. After the unstable, it divides into 2 equal parts. Barium 56-144 plus krypton 36-89. Right? Plus 3 neutrons are also produced as a product, and Q amount of the energy is released. This energy Q is not obtained as a bunch, but this energy is released in form of kinetic energy of the product and also the kinetic energy of the neutron, and also in form of temperature, that means the heat energy. Clear? Okay. Now not only this reaction is formed when the slow neutron is bombarded on the uranium nucleus. The other pair of the fragments are also produced, or are also possible. The same reaction can produce the other pair of the mass fragments. The nuclear reaction is when the neutron is bombarded on uranium 92-235, it absorbs this neutron and becomes the unstable uranium nucleus 92-236, and get divided into the 2 equal mass nuclei. Antimony 51-133 plus niobium 41-99 plus 4 neutron, and Q amount of the energy is released. Other possible reaction is uranium 92-235 bombarded by the neutron. This neutron is absorbed by the uranium nucleus, becomes unstable 92-236, and gets divided into the 2 equal mass nuclei. Xenon 54-140 plus strontium 38-94 plus 2 neutron plus Q amount of energy is released. Okay. The fission fragments are radioactive, and by successive emission of the beta particle results in the stable nuclei. This fission fragment produced due to the fission of the uranium heavy nucleus. This fission nuclei are also radioactive. By successive emission of the beta particle, they try to obtain or achieve the stability. Okay. The neutron produced in this reaction are fast. Almost this neutron have the 2 MeV energy, 2 MeV energy in form of kinetic energy. Okay. Here the Q is the energy, LH. The energy produced in almost 200 MeV per one piston process. In the one piston process, approximate 200 MeV energy is released. And this released energy is obtained as the kinetic energy of the piston fragments and gamma rays. After the emission of the beta particles here, the gamma decay takes place, and whatever the energy of the gamma decay is also in form of, or the Q is in form of the kinetic energy of the fission fragments plus the energy of the gamma rays. Okay. Now there is a nuclear fission process. Sometime complete the reaction for 1 marks question. For that purpose, these 3 and also the 2 more nuclear reaction are important. Frequently there is asked in NEET exam and also the board exam and also the good state exam. Complete the reaction. Here the blank is given like this way, here this. Right? Only for knowledge, our information, the other possible nuclear reaction of fission of uranium are also possible. When the neutron is bombarded on uranium-92-235, this neutron is absorbed, becomes the unstable uranium nuclei having the 92-236 plus I-53-137 plus Y-39-97 are produced as a fission fragment plus 2 neutrons are generated plus Q amount of energy is released. Now the other possible reaction is when the neutron is bombarded on uranium-92-235, it is converted to the unstable uranium nuclei 92-236 plus cesium 55-144 plus lead Pb 37-90 plus 2 neutrons plus Q amount of the energy is released. Again we repeat these two processes. Neutron is bombarded on uranium-92-235, becomes the unstable uranium nuclei 92-236 as a fission fragment I-53-137 plus Y-39-97 plus 2 neutrons plus Q amount of the energy is released. And also, when the neutron is bombarded on uranium nucleus 92-235, after absorbing this neutron, uranium nucleus becomes the unstable 92-236. It gets divided into the cesium 55-144 plus lead 37-90 plus 2 neutron plus Q amount of the energy is released. So in addition, many other pairs are produced whose value of Z between 36 to 56. It means for each fission, the fission fragment are not same. At least more than 20 nuclei having the Z, value of Z lies between the 36 to 56 are possible to produce as a fission fragments. The probability of a pair of nucleus having atomic mass number A 95 to 140 is maximum. Here which pair are produced? The probability of a pair of nucleus having atomic mass number A 95 and A is equal to atomic mass number A is equal to 140 is maximum. So this is the portion of nuclear fission process. Clear? So keep in mind this 3 reaction plus 2 more for knowledge, because the frequently 1 marks question is asked, and also the question of the nuclear fission is also important for 2 marks question. In answer of this nuclear fission process, here these three reactions are important. We have to mention this thing. Okay. Now friends, after the discussion of the nuclear fission process, just we discussed about that as a product we obtain the Q amount of energy, approximate 200 MeV energy, when the neutron is bombarded on the uranium nucleus. How the 200 MeV approximate energy is obtained? So for that purpose, here we take one example. Now a nucleus with the mass number A is equal to 240 and binding energy per nucleon is 7.6 MeV. Divide into two fragments, each of atomic mass number 120 with binding energy per nucleon is 8.5 MeV. Calculate the released energy. During this process, how much Q amount of the energy is obtained or the released? Again, the nucleus with the mass number A is equal to 240 and binding energy per nucleon 7.6 MeV energy. Divide into two fragments, each of the atomic mass number 120 and binding energy per nucleon is 8.5 MeV. Calculate the Q energy of the equation. For that purpose, the binding energy of the nucleus of atomic mass number A is equal to 240 is, that is the EV1 is equal to number of nucleon in a nucleus into the binding energy per single nucleus. That means the binding energy per nucleon. 240 into 7.6, that is the total energy of the nucleus having atomic mass number A is equal to 240 is 1824 MeV. 246 multiplied by 7.6. 240 is the number of nucleon and 7.6 MeV, that is the binding energy per nucleon. Therefore 1824 MeV is the binding energy of the nucleus. Now this nucleus is divided into the two equal fragments of atomic mass number 120. Therefore, binding energy of the two fragments pair of atomic mass number 120 is EV2. Here the two fragments are produced, therefore 2. Number of nucleon is atomic mass number 120 and binding energy per nucleon is 8.5. Therefore 2 into 120 into 8.5, that means 2040 MeV energy is the energy of the fragments. Therefore, energy released, total energy released, that is the EV or the Q value, is equal to final total energy minus initial before the reaction. Therefore, 2040 minus 1824 MeV. Therefore, 216 MeV energy is released. Thus, during each nuclear fission process, approximate 240 MeV, 200 MeV energy is produced. Clear this? So this way we can calculate how much energy is released during the fission process. Now after that the nuclear fission process. Now what is the nuclear chain reaction and explain it. In nuclear fission process we only consider the one uranium nucleus that is bombarded by the slow neutron. That means on the uranium nucleus 92 to 35 is bombarded by the neutron, slow neutron. So we know that as a product we can obtain approximate 3 or the 2 neutron per each fission of uranium nuclei. But in bunch of uranium nucleus or the large quantity of the uranium nucleus, as the 1 neutron is entered in the quantity of a uranium nucleus. So as a result, average 2.5 neutron are generated or they are produced as a product. This we consider here only the 2. Actually the 2.5 average protons and neutrons are produced. These produced neutrons are passed and again it reacts with the another uranium nuclei 92 to 35. The same manner, uranium 92 to 35. Again the 2.5 neutrons are produced. Here again the 2 neutrons. So at the second stage, there is the first stage, 1 neutron is incident or the projected. As I said, the 2 neutrons are produced. These 2 neutrons again react with the other uranium nuclei and produce the pair of the neutron. Therefore, in the third stage, we obtain the 4 neutron. Actually, the 5 neutron. And this neutron again react with the another uranium nucleus, again produce the 2. So thus the one chain is formed. One chain is formed. That is known as the nuclear chain reaction. That is known as nuclear chain reaction. Again, when the uranium nucleus is bombarded by the slow neutron, as a product, the average 2.5 neutron are produced as a fission product. Why the 2.5? Because in some reaction, the 3 neutrons are produced. In some reaction, the 2 neutrons are produced. Therefore, Fermi suggested that we consider the average 2.5 neutron produced per each fission of each uranium nuclei. So this produces the neutron react with the uranium nuclei and produce again the neutron. This produced neutron again react with the uranium nuclei. Again, the 2.5 neutrons are produced. So here, the one chain of the fission process is produced. Therefore, this process is known as the nuclear chain reaction. This figure is only for your understanding. Right? Now, what is the definition of the nuclear chain reaction? And we have to explain it. From the fission of the uranium nucleus by a single neutron, more than 1 neutrons are obtained. When the 1 uranium nucleus is fissioned by the single neutron, more than 1 neutrons are obtained as a product. Average 2.5 neutrons are released by fission of the uranium nucleus. It is fraction since in some fission events the 2 neutrons or in some 3 neutrons are produced. Here the more than 1 neutron produced, that means in some process the 2 neutrons are produced, while in some process the 3 neutrons are produced. Therefore we take the average value of the produced neutron is 2.5. The extra neutron in turn can initiate the fission process producing the more neutrons. What are the neutrons are produced due to the fission of each uranium nucleus? This produced neutron are initiate the fission process and producing the more neutron. This leads to the possibility of the chain reaction as was first suggested by the Fermi. Fermi was the first physicist which suggests the nuclear chain reaction. Initially we discussed only the fission of the single uranium nucleus by the slow neutron. As a result, more than one neutron are produced. But in some fission of the uranium nucleus, 2 or the 3 neutrons are produced. Therefore, we consider the average value of the neutron produced by each fission of each uranium nucleus is 2.5. And this exit neutron produced can initiate the fission process and produce more neutron. And this fact leads to the possibility of the chain reaction that was first introduced by the Fermi. Now, if the chain reaction is uncontrolled, if this chain reaction is uncontrolled manner, it leads to the explosion energy, or the explosive energy output as in a nuclear bomb, right? Which would prove the destroyers. So in a nuclear bomb, the nuclear chain reaction, that means the process take place, but there is a uncontrolled manner. Once the bomb is start the fission process, we can't stop it. So there is the uncontrolled manner. Right? If the chain reaction is uncontrolled, it leads to the explosive energy. Right? Output as in a nuclear bomb. Okay. If the chain reaction controlled properly, then the energy we get at a constant rate. If this chain reaction is take place under the controlled manner, so in this condition we get the energy at a constant rate that can be used for the good purpose, and that is the principle of nuclear reactor. At present, we obtain the electricity with help of the nuclear reactor, or the nuclear chain reaction take place in nuclear reactor. But here, what are the chain reaction take place in nuclear reactor? There is totally controlled manner. If there is the uncontrolled, at that time the nuclear bomb take place. That happens as a nuclear bomb, and the last destroyer is produced because no control of this process, so it produces the last destroyer. So when the uranium nucleus is bombarded, or the fission of the uranium nucleus takes place by the bombardment of the slow neutron, so as a result, more than 2 or 3 neutrons are produced as a product. This neutron react with the other nuclei and produce the more neutron. These neutrons are the fast neutron and would can initiate the other process and produce the more neutron. This leads to the possibility of the chain reaction suggested by the Fermi. This chain reaction are 2 types. One is uncontrolled manner, second is the controlled manner. If the chain reaction is take place in uncontrolled manner, so it leads to the explosive energy output as a nuclear bomb. And if the nuclear chain reaction take place in control properly, with a controlled manner, so that is the principle of nuclear reactor. We get the energy at a constant rate, and this energy is helpful us. Right? In next lecture, we discuss about what are the difficulties arises in nuclear reactor or the nuclear chain reaction, and how we overcame these difficulties. That is the most important question.